Section 3, right triangle trigonometry. These are the objectives. You can read them. Pause the video. I am going to move on to the next slide. This is the vocabulary key concepts from this section. And again, I am going to move on, but you can pause so you can read this slide. Let me read this to you. This is something you probably have seen. Right triangle definition of trigonometric functions. Let theta be an acute angle in a right triangle. And you knew this from geometry. Excuse me, going back. Given any right triangle, theta, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and so forth. And the reciprocals, you see them here, and you know the relationship between the reciprocals and sine, cosine, and tangent. I am moving on to the next slide. This is new. This is well, actually some of these are new. These are the fundamental trigonometric identities. These are the reciprocal identities, and I think you know why. These are the quotient identities. Tangent is the same thing as sine over cosine. Cotangent is cosine over sine. Moving on to the other one, these are the Pythagorean identities, because you have the a squared and b squared or whatever equals something. Now, you have to know these. You should know how to come up with these, given sine squared plus cosine squared equals theta. Talk to me in class, and I'll show you how to derive the other ones. But I am going to give you an f squared on this slide, and this is what you want to prove. Just if you have some spare time and you're bored, try this, and then you can show us or show me in class. I am moving on to the next slide. This is number 1. It says find the exact values of the trigonometric functions of the angle theta shown in the figure. So the first thing you want to do is find the missing side in this right triangle using a little bit of algebra, applying the Pythagorean theorem. You just know that this is 12, or you can remember this if you remember from geometry. These are Pythagorean triples. So now if I want to find the sine, the cosine of this angle theta, I know it's opposite over hypotenuse, cosine is adjacent over hypotenuse, and then you have those values to the right. Tangent is 5 over 12, which is your opposite over your adjacent, and then these are just the reciprocals of the sine, cosine, and tangent. Moving on to the next slide. This is number 2. It says sketch a right triangle corresponding to the trigonometric function of the acute angle theta. Use the Pythagorean theorem to determine the third side of the triangle, and then find the other 5 trigonometric functions of theta. Cotangent of theta is equal to 5 by definition. You know that it's adjacent over opposite. You know that this is the same thing as 5 over 1. From here, we're able to generate this right triangle. The hypotenuse, using the Pythagorean theorem, radical 26. Then sine of theta is just 1 over radical 26. Rationalize, we get this. Cosine, 5 over radical 26. Rationalize. Tangent, this is cosecant of theta is the reciprocal of sine of theta. You can work with this, or this one is a lot easier, because if you work with this one, you're going to have to rationalize. So this one will be a lot easier to compute the cosecant. Same thing for the secant, and you knew the cotangent. And then secant. Again, don't take the reciprocal of this one, take the reciprocal of this one, Moving on to number 3. Use the given function values and and to find the indicated trigonometric functions. Secant of theta is 5, tangent of theta is 2 radical 6. If you take this information and use a right triangle to transfer it, this is what we get. And then once we have this, I can find, say, sine of theta very easily, which is your opposite over your hypotenuse. Your cosine is your adjacent over your hypotenuse. Your cotangent is adjacent over opposite, which means you have to rationalize, simplify. And this is the one that's a little bit tricky, cotangent of 90 minus theta. If you look carefully, this right here, change the color, this is 90 degrees. I mean, this is, I take it back, this is your theta. Now you're looking for 90 minus theta. Where is this angle? This is your 90 minus theta. So this is now your reference angle. Since you're looking for cotangent of this angle, 90 minus theta, cotangent is adjacent. Here's your adjacent over your hypotenuse, over your opposite, I'm sorry. So that's why this is the answer to letter C. Adjacent over opposite. Definition of cotangent. And since this is your reference angle, answer. Moving on to the next slide. This is a let me just read the directions. It says use trigonometric identities to transform one side of the equation into the other. And this is just a little technicality that we must write. Otherwise, it may or may not work. But you don't have to worry about this. So you're trying to show that the left side is equal to the right side. So what you usually do when you try to prove that one side is equal to the other, you want to focus on the complicated side. Notice that this looks more complicated, the left side, than the right side. So what I'm going to do, I'm going to work on the left side. I am going to be using the identities that you saw on an earlier slide. This is the reciprocal identity. This is one of the quotient identities. So from here, I know that this cancels out. So I have 1 over cosine of theta, and I know that one of the reciprocal identity tells me that this is equal to secant. Number 5, same thing. Show that one side is equal to the other. The left side is more complicated, so I'm going to start working on that side. I work on the left side. This is the quotient identities. I leave this alone. What happens here? This cancels out. I'm done. Moving on to the next slide. A little more complicated, same directions. I want to show that one side is equal to the other side. The left side looks more complicated, so I'm going to work on that side. If I apply FOIL, this is what I get. And then at this point, I am going to use one of the Pythagorean identities. Here, get a pen. This is equal to 1 plus cotangent squared theta. Bring the sign down, bring cotangent squared theta. I can simplify this, and that's how I end up with 1. Number 7. Left side looks more complicated than the right side, so I'm going to focus on the left side. From here, I'm going to use a basic fact that you learned in pre-algebra. Given that you have this numerator, the sum of these two trigonometric functions, I am going to rewrite them with their own denominator. So this is what you get when you give them their own denominator. From here, you should be able to see that this is 1. I leave this alone. I know that this is 1 over cotangent of theta. From algebra 2, you should know that this becomes cotangent squared theta. If you need help with this, I'll clarify it in class. Just ask me. And this is one of the Pythagorean identities, which you use over here. That's why this is equal to cosecant squared theta. So this is number 8. In traveling across flatland, you notice a mountain directly in front of you. Its angle elevation to the peak is 3.5 degrees. After you drive 13 miles closer to the mountain, the angle elevation is 9 degrees. Approximate the height of the mountain. You should agree with me that we can label the height of the mountain as h, and the distance from this location here, the end of 13 miles to the bottom of the mountain, we are going to call it c. I am going to apply cotangent of 9 degrees. I know that this is a right triangle. Then from here, I know that is adjacent side over opposite side. 9 degrees as my reference angle. Right triangle is the adjacent side is now this distance, which is 13 miles plus c, over the height, which is your opposite side. There's a reason why we're using cotangent instead of tangent, and if you want me to clarify why, talk to me in class. From here, I just use a simple fact of pre-algebra, that I can rewrite each of these numerators with its own denominator, which I get this, and then I notice that c over h is equal to cotangent of 9. This gives me 3.5 degrees. Cotangent of 3.5 degrees equals 13 over h plus cotangent of 9 degrees. I'm solving for h, so I'm going to isolate the 13 over h. At this point, I can do a little bit of pre-algebra again. Cross multiply and then solve for h, which means that I have to divide both sides by this, and that's how I end up with this. I punch this into the calculator, and this is what I get, 1.3 miles. And this is the height of the mountain. Problem. The Johnstown Incline Plane in Pennsylvania is one of the longest and steepest hoists in the world. The railway cars travel at a distance of 896.5 feet at an angle of approximately 35.4 degrees, rising to a height of, you can read the number, above sea level. It says find the vertical rise of the indicated plane. So they're talking about this distance from here to here. I'm going to call it x. So then I can use the fact that this is the opposite side. I know the hypotenuse, and this is a right triangle. Solve for x. I get 519.3 feet. Part B says find the elevation of the lower end of the inclined plane. So this is the lower end. And so this somehow continues. And somewhere down here, we have a sea level. So you're trying to find the distance from sea level to this portion, the lower end of the inclined plane. So all we need to do is take 519 and take that away from this point right here, and that's how we get this, the elevation of the lower end of the inclined plane, which is from here to sea level, 1,174.2 feet above sea level. The last part says that the cars move up the mountain at a rate of 300 feet per minute. Find the rate at which they rise vertically. So what I'm going to do first is I'm going to determine the time that it takes for the cars to move out the mountain. They need to travel, use a pen, up this portion of the hill. So they need to travel this distance. This is the rate at which they travel. So then I have the distance, which is 896.5, the rate, which is right here, So I substitute that in. This how much time it takes to travel from the bottom here to the top. Now, this is not what I'm looking for. I'm still looking for the rate at which this train rides vertically. So I'm looking for the rate going from here to here, not traveling along this path. So this is what I need to do. I know that rate is equal to distance over time. So now, what distance what is the distance from here to here? We found that already in part A. So I'm going to take that distance. I'm going to take the time that I found on this part C, which is 2.89, and that is going to give me the rate of 173.8 feet per minute, and this is the vertical rate going from here to here. This is the end of the video.